Good afternoon and welcome to your science review with Mr. Blades. Today we're going to be doing a force problem including an angle and a coefficient of friction, so let's get started. You can see I've already drawn part of my free body diagram. I've also included my mass, my mu s, and my angle. Let's continue with our free body diagram. There I've just drawn in my force of gravity, our force normal is perpendicular to the surface of the ramp, and our force of friction. It's Fs this time because it's a static friction. Now, the easiest thing to do to start with is to draw our fake triangle. This will give us our forces parallel to the surface of the ramp and our forces perpendicular to the ramp. Now, the easiest thing to calculate, starting with, is our force of gravity. Fg is just equal to mass times the acceleration due to gravity, or in this case, 50 kilograms multiplied by 9.8 meters per second squared. That gives us 490 newtons. Now we're going to need to calculate our perpendicular and parallel forces. Now we've drawn our fake triangle, and the angle at the top of our fake triangle is equal to the angle of our block, or 25 degrees. And that means that since our perpendicular force is adjacent to that angle, our force perpendicular is Fg times the cosine of theta, while F parallel is Fg times the sine of theta. Now if we plug in our numbers, we get 490 times the cosine of 25 and 490 times the sine of 25. Make sure your calculator is in degree mode and you punch those in and you get 444.1 newtons for our force perpendicular and 207.1 newtons for our force parallel. Okay, now that we have all of our numbers, we can start with our summation equations. Our sum of forces in the perpendicular plane is our normal force minus our force perpendicular. And we said minus because the perpendicular force is in the opposite direction to the normal force. And both of those things equal ma. Now, we don't have any acceleration in the direction perpendicular to the block, so m times a just equals 0. Now, if I add the force perpendicular to both sides, we can see that our normal force is just equal to our perpendicular force right there. So let's go ahead and write that in so we can keep track of it for later. Now we're going to calculate our force of static friction. Our equation for that is F of S is equal to mu S times the normal force. Now we've already been given our mu S and we just calculated our normal force. So we can calculate our Fs directly. 0.45 times 444.1 gives us 199.845 or 85 newtons. Now let's go ahead and do our last summation equation, our parallel forces. Our sum of forces in the parallel direction are equal to F of tension, our rope holding the block up, plus our frictional force minus our force parallel, because they're in different directions, equals ma. And again, the problem statement says that we are intended to have no movement whatsoever along the surface of the block, so acceleration is 0 and m times a is 0. Now we can go ahead and rearrange this equation a little bit, and we end up with Ft plus Fs equals force parallel. And if we subtract Fs from both sides, we can calculate our tension force is equal to our force parallel minus our friction force. If we plug in our numbers, we get 207.1 minus 199.85. We punch that into our calculator, we can see that it is equal to 7.26 newtons as soon as I get out of the way. There we go. Now I hope this was helpful, and I'll see you in class.